I think, unlike some of the people in this audience, I would describe my experience and my position here as I have a very broad experience that is very shallow. So what I would say is over the life of my career, I have traveled in lots of places and whittled, whacked, and sawed a large number of branches, trunks, twigs of a large number of trees, collecting a large number of bark and ambrosia beetles. So that's the breadth. The depth, of course, is I haven't worked in detail on particular systems like what we're looking at here. Of course, there's some discrepancy between what it says up here and what it says in the program, and this is just the gap between organizing a program as quickly as this thing was organized and then deciding what I was actually going to say. I've been sitting here listening to the audience for the last couple of days, and I have to say I have learned a whole lot. So I've certainly the depth of my understanding has increased dramatically. But I wanted to diverge from prepared remarks and just pose some questions here based on my understanding or my worldview of ambrosia beetles and who says they breed in dead trees. And I think one thing that has always impressed me is for trees, death and health aren't discrete events. I mean, who can whack your arm off, leave it lying around for a couple of days, stick it in the ground, and there's my new best friend growing a year later? And yet we can go down, and a lot of trees, a branch dies, branch falls off. Is it dead? Well, no, it still shows some signs of it's quickly under severe moisture stress, but it is still intact, it is undegraded. And I think the main thing to understand on bark and ambrosia beetles both, and this is sort of the fundamental niche of the group, is they are right there in that transition zone between live and recently dead or somewhere in between. And the way plants are organized or not organized, this is, especially woody plants, this can take a while. So I think the important consideration is that what they require is fresh material. That is to say, undegraded. It may be a little dry, and as long as the temperature extremes are not, it's not too hot, not too cold, not too dry, just right. And we're looking at, 3,500 species here. So I'd say, we have to look at the spectrum of host interactions ranges from an obligate requirement for living hosts to things that are near saprophytes. So some of the ones, and I'll show you a few pictures based on the pictures I had on my computer at this meeting, where I would say they actually obligate require living healthy hosts. So, and again, the thing about colonization of living hosts and host death is not, again, a immediate, one doesn't necessarily follow the other. And and Randy brought in this paper by Farrell in discussion of the evolution of agricultural beetles. And I think one of the things that's really critical, whether 7 times, 11 times, what happened was at least 3 big times it resulted in a huge speciation. But one of the things that consistently occurred when you look at the different lineages that adapted the ambrosial habit in a big way was loss of host specificity, or you might say freedom of choice, depending on your. And so host defenses seem to be really important. Resins, latexes, gums, monoterpenes, et cetera, for maintaining host specificity and phloem feeders, the true bark beetles. But what I see, and again, speaking as a non-mycologist, that it looks to me like the fungus is the intermediary between the beetle and the host. I mean, in addition to being food source. And I think what is interesting about ambrosia beetles is they only have to overcome a small part. They've got to get through that first 1.5 centimeters where many of the active defenses are located, and they're almost home free. And I would also say that any notions you have of mass attack, forget everything you know about bark beetles. I don't think what we're seeing here is a mass attack. It is in no way comparable to what we're seeing with a Dendroctonus ponderosa starting a tree and then the massive cascade of all these pheromone systems and both sexes responding, et cetera, et cetera. What we're seeing is serial infestation, repeated infestation. So I think maybe a way to look at this is imagine a very large animal, maybe the size of the horse, that's taking chunks, bites out of that tree and branch that are the size of a grapefruit, takes enough chunks out and the tree dies or falls over. We're not unlike the laurel wilt, we're not seeing a systemic infection. Well, I think in a lot of cases, based on collecting out in the woods, is that many times you actually see a sort of peaceful coexistence in natural settings. And maybe sort of a parasite load, but not necessarily so I think a lot of these things are flying under the radar. And what we're seeing here is a lot of things are out of balance. Now, this is Cortholis. Randy his graph had some Cortholis. This is actually in Mexico. And you say, big deal. We've seen this picture the last 2 days. Entry hole, little staining. What's interesting, the reason this came to my attention when I was in Mexico was not because it was killing branches. No, but the growers came because the fruit had set. And the branch broke because it's so heavy from the pears on it, not any kind of flagging. So the normal reaction, what you'd see, is a little canker, no gum, no wet, no sugar volcanoes, and then the next year it would heal over. And what would happen was the inner center had been mined out. As that branch grew, and then if there'd be other attacks on the same branch, they would structurally fail. But other than that, if they hadn't been worried about fruit crop, nobody would have ever noticed. This is Xylosandrus compactus, and this, made a lot of noise early on. And this is one, actually both these I would consider obligate, require healthy hosts, but they don't. And I'm just showing branch feeders because that's all I got pictures of. There are some trunk feeders that would fit in this category too. So a lot of times, it kills the twig, flags, that's what got everybody excited, but if the twig's big enough, thing heals over. 2 years later, you can't see any exterior sign that thing was ever infested. So anyway, I just say as an alternative model to sort of think about this is, you look at this discrete, limited breeding in susceptible hosts, non-pathogenic or weakly pathogenic. The host recovers, in some cases can maintain a certain parasite load. And again, I showed branches, but there are some examples of trunks. So that's back to what I'm supposed to talk about. This is a picture taken near the university campus, Box Springs Mountain in the background. And I'm not from California, but when I worked here, this always impressed me, and I've kept this picture as sort of a reminder of where we are right now, the difference between the urban forest and the wildlands. I mean, some of the wildlands look a little more vegetated than this, but this is still not a bad way of looking at it. And I'll give you my conclusions first in case I run short. So, Southern California, it may seem odd, I'm telling you, this is a lousy place for ambrosia beetles, but we're all here because you do have an ambrosia beetle, and it's doing pretty darn well. But just a little perspective, but this is true for natives as well as exotics. And I think what we're going to see here is it's still going to be the predominant habitat is the urban forest. And I think that also it's very good and very interesting to have the experience of the laurel wilt, but our experience here is going to be fundamentally different, community ecology level, than what we're going to see anywhere in the eastern United States or southeastern Asia, southern Asia. And it basically has to do with humidity. If we look at western ambrosia beetles, the natives, they're mostly restricted to high moist or high elevation forests. They're mostly host specific, which is not necessarily the norm for ambrosia beetles. Pines, oaks, firs, and historically they're absent from the large urban areas. So if you looked at if you're able to do a survey in about 1,700 of the LA basin, you wouldn't find many ambrosia beetles in it, of the natives. And relatively little spread into urban areas except for oaks. And that's because oaks are partly in the transition zone, and some of the areas that are urbanized are where oak forests are near that oak woodland. So I'm just going to run through very quickly, and all I want you to understand from this is the pattern. You're seeing the same pattern again and again. This is a platypodid, lives up in fir forests. Again, so what you're seeing, this is a land use map, and the green is conifer forest, and the points track that green. This is Xyloleberus intrusus, a host-specific native associate. Again, the dots track the green, goes down into Mexico. Tripodendron, all these are conifer breeding. I think this location from Big Bear may be bogus. Nathotrichus striking a little more fuzz. There are 3 species here, and one of them does get into oaks. And so, son of a gun, we got some here in the LA basin. Monarthrum, again, these are in oaks, and we're actually seeing quite a bit of Bay Area sort of urban involvement. So the key is, some of the oak species do, in fact, come across the wild land. And in nature, you might say these things are basically host-specific for oaks because that's really about all they got to feed on. And I really would like to know if they, once they get into town, do they eat other things? And these are secondary, I'd say. If you look at the east, I think that one of the biggest differences, any species you got, native or exotic, is going to be widely distributed throughout the region. And they're a mix of host generalists and host specialists. And they do well in Manhattan, they're in Central Park, they do in any urban area as long as the host and required conditions are met. There's no gap between the wildlands, the urban core to the suburbs, to the wildlands, to the agriculture. They're everywhere. So these are another 2 species of Monarthrum that are eastern, and the point is they're just everywhere. There's no local microscale or macro scale, we're looking at the same pattern. I just chose the eastern states, similar latitudes, and basically the east has about 3x the number. Whether we're talking about natives, exotics, they're 4 times as many in the east, and the total is about 3x. And again, back to my comment about the suitability of the environment. And so these are, one of the things about this is the native faunas. So I showed you a platypodid, I showed you Nathotrichus, Tripodendron, Monarthum, same genera in the east, Xyleberus. We're talking about something that goes back to the separation of the eastern biota from the western biota in North America. This is a long-standing pattern. And really, if you look, while it is certainly true, indisputably true that ambrosia beetles are most diverse in tropics, at any given latitude, the difference is moisture. Not rainfall necessarily, I think it's moisture deficit. I mean, how much is moisture is available for that fungus to grow. Okay, when you look at the exotics, yeah, there's some that came across from Europe way on, but even those that probably came to North America from Europe, most of those are Eurasian. And the suspicion is all these other things that Bob was showing you yesterday are the really Eurasian that probably come from Asian trade, less so than Europe itself. And I think one of the things to keep in mind is, considering the amount of activity at the Port of Long Beach and Port of Los Angeles, I don't think it's because of lack of opportunity. I think you're probably hitting the same flow of potential immigrants as this don't take here as well. Okay, now I've told you why you don't have a problem because of bad ambrosia beetles, but of course you do have a problem. Xyleberus saxescini is when you start plotting this thing, and this likes it in town. I mean, it's probably out there. I don't really know from these maps how far out in the woods, but it certainly does well in town. And you can just see from these crude level maps. Monarthur Malley, this is actually one of the native eastern North American species, has been transcontinentally introduced. And again, I mean, this is in fruit trees and stuff in the agricultural urban zone. So I mean, I think one of the things that when we do get ambrosia beetles, actually, the Northwest is a lot greater risk from ambrosia beetles than, overall, than Southern California. But when we see the exotics, they're a lot more likely to be found in the urban and agricultural settings. And I think it still is an open question is how successful these things are going to be at invading the native plant communities. Whereas back east, the exotics are abundant in communities regardless. I mean, I guess you couldn't really say there's any place that's undisturbed in the eastern U.S., but I don't care how remote, you can go in the Great Smoky Mountains National Park and you'll pick up the same old trap trash you'd pick up downtown Atlanta. So, looking specifically, these points, we're talking this, the few that I could assemble from any kind of memos, emails, and extension notices before coming out here. So I knew the Long Beach and the Huntington and the Arcadia, and this is O'Keefe's arguable San Diego record. And the main thing to keep in mind here is the red is the urban area. And yeah, we got nice forests up on the mountains, and this map doesn't really distinguish well oak woodlands. And I think though the important thing to keep in mind is, this is O'Keefe's, he sent me a version, so you saw a better version with his maps of a particular early survey with Richard and O'Keefe. This is, I guess, everything from driving down the streets and whatnot. This is a map I got from the Avocado Commission, and this is where commercial avocado production occurs. So the big northern San Diego, a little bit in Riverside, I guess this is around south of Corona. Lots of the coastal valleys in Ventura County, along the coastal strip in Santa Barbara, and then scattered localities in San Luis Obispo. And of course, the reason we're talking calmly is these points don't touch those yet. But I think what really matters is clearing up that land use a little bit is that, regardless of whether it gets into the oak woodlands on the foothills of the mountains, this is really going to be our corridor. Is the urban places where people in their yards, along the streets, have well irrigated, at least susceptible hosts, if not necessarily preferred hosts, but at least susceptible hosts, and coast live oaks seem to be preferred and susceptible as a route for the spread. So, maybe the good news is that northern San Diego is not quite as well connected. But so far it looks to me like while we may have unaided aided spread, it appears to be, you know, sort of wherever the original point was, whether it's a port or a little inland, it still is spreading out mostly from that core. Okay, so anyway, that's, I think we've already covered this. And I guess the question about the urban horticultural, is this a good thing or a bad thing? And on the one hand, you potentially, once we open the can, open Pandora's box and sound the alarm, you have a lot more people looking. You have a better chance of following this up. But of course, I don't know if this is going to be a resource conflict down the road. Okay, one thing I originally think, you know, what could I introduce here? I do maintain a website. I invite you to come visit barkbeetles.com. I've got a online catalog of the bark beetle and ambrosia beetles of North and Central and North America, U.S. and Canada. And I think one thing I could help on is, has been frustrating to me preparing for this meeting is I know people have survey work is offered to provide a central clearinghouse where we could actually not post this for, you know, general comment, but I would act as moderator to, and you tell me whether you want this allow this information to be seen by anyone or by password protection. Somebody else wants to do this, I'd be happy to let them do it. But I would say no user direct input, because that's a programming challenge and you're hackable, whereas if you just send it to me and I promise to get it up within a week, the main file is not online anywhere, it's not vulnerable, you can't sign in. And just, I guess, you know, what's in it for me is, so many times when we get these exotic beetles coming in, we had the big uproar, everybody gets excited, runs around, takes a lot of samples, and then those surveys go into the drawers, a little bit gets published, the rest of it gets forgotten, and then we never really have the chance to track it. So, and somebody is sooner or later going to be running a lot of traps here. You're going to be doing manuka oil, is that the right way? No, it's manuka. We were told specifically it's manuka. I can't get the accent you have, but, or ethanol. And I'd really be curious to see what these other things you get in the traps. So I also volunteer to identify any bark beetles. None of this, keep your serum business, keep your psyllids, but any ambrosia beetles I'd be happy to ID for you. So my time's up.